Hello everyone. Welcome to the BigLake Manifest files with Delta IO format. So in this video, we're going to go through how to use BigLake Manifest files to query Delta IO. So I'll also cover a native approach for Delta in a different video. So this video is going to show you how you can use a manifest file. So when you have Delta, Hudi, and other file formats, sometimes they have a manifest file that lists, for example, the Parquet files that are in the current version of the data. So Delta and Hudi will mark some files as logically deleted, and then if we were to query that data, we would include the logically deleted data. So the manifest files specify which files are not logically deleted. So we'll go through this and see how this works, and we'll also use query acceleration for these files. So let's jump in. We're going to head over to the taxi dataset, and we'll go to a routine, and the routine is going to be the manifest. There's previously a workaround approach, so I've renamed that one, but we'll jump into the manifest approach. Let's edit this store procedure. So the first thing you can do, there's some instructions here on how to create manifest files. Depending upon the technology you're using, you can run a SDK command to generate these files, or sometimes you could decorate a table with a property saying when this table is updated, the manifest files should be recreated. So let's go ahead and create a table and we'll take a look. And also we could open up and look at the storage system. So I'm going to run that, and let's go take a look at the storage. So I'm going to go to cloud storage and buckets, and believe this is in the process bucket. And we look at Delta IO, rideshare trips. You can see we have some partition files here, and we also have a manifest files. So our manifest files, we have one manifest file per partition, and we're going to open these up with our BigLake create table command, and we'll see what files should be included in here. So if you were to query this data without the manifest files, you would include too much data. So let's take a look at the BigQuery command. So here you can see we have our Hive partitioning, and we have our URIs. So this is specifying how our data is partitioned and where to go look for this data. And then we're saying the file set type is new line delimited manifest. So we're expecting one line to point to one file, and our format will be Parquet. So this first table simply creates the query, and we have some partition, first query creates a table, and then we have some table partitioning within that table. So let's go ahead and query this. So we're going to run this command, and we should see our data. So what it's doing behind the scenes is opening up those manifest files, and then we're going to see the data. So here you can see our data has been returned, and we get a warning here that we'll dismiss. It says you should enable metadata caching, which we're going to do in a second to increase your performance. So very easy to use, and this works with anything, any set of files. Maybe you have a 10,000 CSV files, you could create a manifest file and put them in there, and then we could do some caching on that. So also works with Hudi. So let's go ahead and create the table. And in this case, it's the same set file spec, but we're going to cache it. So what we're going to do is cache the manifest contents of those manifest files, so we don't have to go to storage and do a listing. So it's very expensive to go to your storage system and get a listing, especially when you're talking about millions and billions of files. That will take a very long time. So what we'll do is we'll go ahead and read the manifest files in and store them within BigQuery. So now BigQuery will query itself to determine which files on your storage system it should go query. So since we're doing a demo, I don't want to wait for any type of refresh. So you can specify different refresh intervals here. So I did manual, so we should have our results instantly available. So let's go ahead and run this. And this is going to return the same exact results, but instead of going to the storage system and doing a directory listing and finding all the files and then reading them, the data has been cached within BigQuery. So very easy to do. Next piece here is we're going to do some aggregations. So typically, you want to expose this data to your users summed up. So what we'll do is we'll create a materialized view on the cache data set, and then we'll be able to provide these aggregations to end users. So let's go ahead and query that table. So we'll just run a select star here, and this is querying your materialized view, and we have a set of averages. So it works just like a regular table. And then the last piece is we're going to apply row level security, and we're going to do this to the cache table. So I'm going to go ahead and create a policy that will filter rows for specific users. It could be groups or domains. And in this case, I'm filtering for pickup location ID 68. And we will query the table again, and we should have data just for that piece here. And you see our pickup location is 68, and we get a warning that we have a subset of data. Now, since we have security on the table, if you query the materialized view, this will also limit your data. So you'll get pass-through security through your materialized view, since the underlying table has had a policy put on top of it. So again, this is a great way to do any type of external format that supports the manifest files. You can go ahead and create a BigLake table that will then read the manifest files and query that data. In addition, you can put query acceleration or your caching of those data elements to make your experience even faster. That's all there is, and thank you for watching.